For example, if your Singleton stores a list of users, that list will grow until the app crashes.
Welcome back to Crushing Design Patterns in .NET. In our last episode, we mastered the factory method to let subclasses decide which objects to create. Today, we are exploring a creational pattern that is both famous and infamous, the Singleton Pattern. Its goal is simple: ensure a class has only one instance and provide a global point of access to it. But with great power comes great responsibility. Let's see how our expert Aarohi navigates the uses, the pitfalls, and the modern alternatives to this classic pattern. Aarohi, welcome. In today's scenario, we are building an application that needs a centralized way to manage its configuration settings. These settings need to be loaded from a file once at startup and then be accessible from many different parts of the application. We must ensure that we don't have multiple conflicting instances of these settings. How would the Singleton pattern help solve this? What is the classic textbook implementation of the Singleton pattern?
The classic implementation has three key ingredients. 1. A private static field to hold the single instance of the class. 2. A private constructor to prevent anyone else from creating an instance with the new keyword. 3. A public static property or method, often called instance, that provides the global access point. It creates the instance the first time it's accessed and returns that same instance on all subsequent calls.
You mentioned this classic implementation is not thread safe. What does that mean and why is it a problem?
That's the biggest pitfall of the simple implementation. In a multi-threaded application, it's possible for two different threads to enter the if_instance == null block at the exact same time. Both would see that _instance is null, and both would proceed to create a new app settings object. The result is that you end up with two instances, which completely violates the core principle of the singleton. This is a race condition.
So, how do you create a thread-safe singleton in C#?
There are several ways, but the simplest and most common in modern C# is to use a static read-only field with a static constructor or initializer. The .NET runtime guarantees that the static constructor is called only once, making it inherently thread-safe. This is a very clean and robust way to implement it. Another popular method involves using lazy of t to ensure the instance is created only when it's first accessed in a thread-safe manner.
The singleton pattern is often criticized. What are some of its main disadvantages?
This is a very important interview question. The criticisms are significant. 1. It violates the single responsibility principle. The singleton class is responsible for its own business logic and for managing its own lifecycle and ensuring its uniqueness. That's two responsibilities. 2. It creates tight coupling. Because it provides a global access point, appsettings.instance, any class can reach out and grab it. This tightly couples the client code to the concrete singleton class, making the system rigid. 3. It makes unit testing very difficult. This is the biggest problem. Because the instance is static and global, it's very hard to replace it with a mock or a fake version for testing. Tests that rely on a global state are not isolated and can affect each other, which is a major red flag.
Given those disadvantages, what is the modern preferred alternative to the singleton pattern in ASP.NET Core?
The modern alternative, and the one you should almost always use in ASP.NET Core, is to leverage the built-in dependency injection, DI, container. Instead of the class being responsible for its own lifecycle, we let the DI container manage it.
How would you register our app settings class with the DI container to behave like a singleton?
It's incredibly simple. In program.cs, you just register the class with a singleton lifetime. Now, the DI container guarantees that only one instance of app settings will be created for the entire application's lifetime.
And how would other classes get access to this single instance?
They would not use a static instance property. Instead, they would simply request it in their constructor. The DI container would automatically inject the single shared instance.
Dependency injection approach over the classic singleton pattern.
The benefits are huge. 1. Decoupling. Some service is no longer tightly coupled to the concrete app settings class. It depends on an abstraction. Even if it's just the class itself in this case, it could be an interface. 2. Testability. This is the massive win. In my unit tests, I can now easily create a mock app settings object with test-specific settings and pass it into the sum service constructor. My tests are now completely isolated and reliable. 3. Adherence to solid. The class is no longer responsible for its own creation, SRP, and we are depending on abstractions, DIP.
So, is the classic singleton pattern ever a good idea in modern .NET?
That's a subject of much debate. In a modern ASP.NET Core application with a built-in DI container, it's very rare that you would need to manually implement the singleton pattern. The DI approach is almost always superior. However, it might still have a place in scenarios without a DI container, like a simple console app, a Unity game, or legacy code. But even then, you must be very aware of the testability challenges you are creating.
When an interviewer asks you to implement a singleton, what are they really testing for?
This is a great question. An interviewer who asks this is testing for much more than just your ability to write the pattern. They are looking for 3 things. 1. Concurrency awareness. Do you know about thread safety and race conditions? 2. Architectural pragmatism. Do you understand the disadvantages, like the violation of the single responsibility principle and the impact on unit testing? 3. Modern knowledge. Do you know that in a modern .NET environment, add singleton in the DI container is the preferred way?
How does a singleton differ from a simple static class?
This is a classic senior question. A static class is just a collection of methods. A singleton is a real object that can implement interfaces, be passed as a parameter, and support inheritance. Most importantly, a singleton can use lazy initialization, whereas a static class is loaded as soon as the application starts.
Can you show us the modern lazy of T implementation for a singleton?
Absolutely. This is the gold standard in modern .NET. The lazy of T type handles all the thread safety logic for you behind the scenes. It's clean, efficient, and very hard to mess up.
Why did you use the sealed keyword in that example?
Great catch. If the class isn't sealed, a developer could technically inherit from it. If they create a subclass with a public constructor, you suddenly have multiple instances of your singleton. Sealed ensures the architecture remains rigid and protected.
What about the double-check locking pattern? Is it still relevant?
Before lazy of T, we used double-check locking with the volatile keyword to ensure thread safety. While it's good to know for legacy code, it's very verbose and easy to get wrong. In 2026, if you aren't using DI or lazy of T, you're writing outdated code.
Can a singleton be destroyed or disposed of?
In the classic static instance pattern, no. The instance lives as long as the app domain. But if you use the DI container, add singleton, you can implement iDisposable. When the application shuts down, the container will automatically call dispose for you. This is another reason why DI is superior.
How does the singleton pattern behave in a distributed system or microservices?
This is an architect-level insight. A singleton is only a singleton per process. If you have 5 instances of your microservice running in Docker, you have 5 singletons. If you need a truly global single instance across all servers, you need a distributed lock or a centralized service like Redis.
Can reflection break a singleton?
Yes. Even with a private constructor, a developer can use reflection to access that constructor and create a second instance. This is why we say a singleton is a pattern, not a security feature. You are trusting your team to follow the architecture.
What is the risk of state leaking in a singleton?
Since a singleton stays alive for the whole app duration, any data you store in it stays there forever. If you're not careful, you can create a memory leak. For example, if your singleton stores a list of users, that list will grow until the app crashes. Singletons should ideally be stateless or hold very specific, limited data.
How do you handle generic singletons?
Some people try to create a base singleton of T to avoid repeating code. While it looks clever, it often leads to complex code and issues with static field sharing. It's usually better to keep it simple, or, once again, let the DI container handle the generics for you.
Final question, is singleton an anti-pattern?
Many people call it an anti-pattern because it's often abused as a hidden global variable. It makes code hard to track and test. My advice? Use it only when a single instance is a strict business requirement, and always try to implement it via dependency injection first.
Aarohi, that was an incredibly nuanced and professional explanation. You've not only shown us the how, but more importantly, the why and why not of the singleton pattern. If you now understand when to use a singleton and when to use dependency injection instead, give this video a like and comment below with your thoughts on this classic pattern. And don't forget to subscribe to the .NET Way for more architectural deep dives. In episode 7 of Crushing Design Patterns, we're going to solve the problem of incompatible interfaces. It's time to learn how to make two different systems work together with the adapter pattern. Thanks for watching. We'll see you in the next episode.